Um, since I always start over here, I'm not going to break that. Today, we'll finish up the last two problems from 1.5. I did the last two parts of number 19 in the co-rec this morning at 8:30. Part F, part G of number 19. I'm not going to ask you to do that on a test. We're not going to do that kind of a translation or transformation on a test. But if you want to see how it was done, I direct your attention to the 8:30 view, Tuesday, Thursday, correct? We did A through E on Tuesday. We're going to finish up. There's two more that I want to show you from 1.5. We'll do 1.6, hopefully 1.7. We'll see. I'm going to give you the review sheet because you can do the first 23 out of 24 problems on the review sheet without seeing 1.7. Okay, all but one. The review sheet will also post. That way, here's the deal. If I gave you the review sheet on Tuesday next week and we review on Thursday, that gives you just a day, 2 days. This way you have it all week to wait until next Wednesday night to try. Because you're just going to throw it away and lose it out. Tuesday we finish everything up, wrap it up. We'll try to start reviewing that as well. Thursday's review. Tuesday the 8th, chapter 1 homework is due, and your test. Homework is due. You have to have your assignment sheet as your cover sheet. You follow the directions on your assignment sheet. You're going to score all your homework. You're going to add them all up. First thing we do on the day of the test is I'm going to collect all the homework. You can turn it in. I'll have the card up in the front. Turn your homework in here. At 10 o'clock, I start to go through the homework, or probably before, I start to go through the homework, and I'm looking for, is anybody's name missing? Have your name on it, first and last name, please. I think Monday, Wednesday, there's the class has like 3 or 4 people who named Daisy. So they just write Daisy. It's like, I don't know who that is. Anyway, name is on it. Did you actually score your homework? Did you add the numbers up? When you score your homework, please no decimals. You're not, figure skating 9.7s, 4.8s. Just if it's a 4.8, round up to a 5. I'll never know. I go through it and I see how well you graded your own homework. I would not look at the decimals in between. I look to see how many you actually tried. Is it neat? Is it organized? Those kinds of things. Do they look like they're just answers copied from the back of the book? What is it? How those are things I look for, the integrity part. So it's all in the direction. Do not fill out that bottom little row. That's where I do the work out of 20 points. That stuff. If you need an assignment sheet, I have copies. You can always ask. It's in the announcements. It was emailed. You can print one out. Don't show up on the 8th trying to put all your homework together, because we will wait until the homework is collected before I'll let you guys start the test. So if there's one person or 2 people trying to put everything together, we're waiting on that 1 or 2 or 3 people before everybody else gets to start. May not seem fair, but you've had a month, and some that already get it done. It should be ready to go. You should have 1 through 5 almost done. Nice and neat. Maybe I kept in a Mylar sleeves, vacuum sealed, so it doesn't get dirty, doesn't get organized. And one last thing, stapled. One staple all the way through. You have to go out to the work shed and get an industrial stapler, which just means why aren't you writing on both sides? Why writing so big? Conserve paper, conserve trees. They were living things. Well, they're not going to die for your grade. Okay, but just try to organize a little bit better. Work on both sides. That's perfectly fine. Okay. So, absolute value x minus 4. So A, B, C, D. Process of elimination. You can eliminate off the bat A, B, C, or D. Which two? A and B. Cannot be in any way, shape, or form A or B because that's an absolute value. Absolute value is a B shape, so it can't be either one of these first two. So now you have two B shapes. C and D. Which one does it have to be? B. C. It has to be C. First of all, the giveaway is it's a positive absolute value. So the B should go up. This one's going down, that one's going up, it has to be C. Maybe it's that simple. Maybe you'll have two. Maybe you'll have two going up. So ignore this one. Maybe it's this one. It'll go up like that instead. So one is this. This is -4. Wait. Here we go. There's +4. So if they're like this, or they're both going up, I see x plus 4, so h has to equal -4. I don't know how I got away with that. But the only one that's been shifted 4 to the left is this one. Now you know it's C because now they're not so different anymore, left versus right. H would have to be a -4. And if you don't remember the whole take out the opposite of what you see, H is always the opposite sign. How about you just plug in -4 if you're not sure? -4 plus 4 is 0. Absolute value of 0 would be right here, -4, 0. If you plug in +4, 4 plus 4 would be 8. Absolute value of 8 is not going to be there. You can take a point and see if it works. I know you think multiple choice is multiple guess. You're freaking mathematicians. Mathematicians don't guess. That's why we do math, is so we don't have to guess. Okay? At least eliminate a few. Make an educated guess. Think. Doesn't it upset you when other people don't think? What are you doing? Off the bat, eliminate what? Just the two possible, definite, not a chance. A and C. Square root, shape of square root looks like that. Well, first of all, since it's a positive square root, it has to go up. Now, the whole 3x minus 4, I have no idea. There's a whole bunch of extra stuff going on. I'll tell you right now. Because of the 3 times the x. There's a whole lot of shaking going on. But the bottom line is, it's positive square root. Down here, that only way that happens is because it's a flip, would be a negative in front. So if I had two choices, one's a positive square root, one's a negative square root, this would only have a negative in front. Because it's a positive, it has to be. All right. H of x. Eliminate which two? B and D. That's a sharp point. Okay. So now you're looking at these two. They're very similar. They're both pointing up. A is a 1. So it's a parabola that goes up. They both go up. The difference is where the vertex is. So the vertex, what's H in that? -5. What's K?
3.
So the vertex is at negative 5, 3. It's been shifted 5 to the left and 3 up. Okay. And if you're not sure, you pick a point. If I pick positive 5, because this is 10, in the middle is 5. 5 plus 5 is 10. 10 squared would be 100 plus 3. If I plug in 5, I'm not going to get 3. I should get 103. Way up there. So this function is not giving me this picture. But over here, if I check this number, if I use h of negative 5, I get parentheses, negative 5, that's my x, plus a 5, squared, add 3. Negative 5 plus 5? So 0 squared plus 3, and 0 plus 3 is negative 5 goes in, and we get 3. Negative 5 to the left, and 3 up. There it is. And then your key swaps. Make that one bigger. And as I keep saying, your bonus will have a piecewise. You'll actually have to grab by hand. But the one on your test will be next. So our graph is separated, x less than 1, x greater than or equal. So the separation between the two pieces is at positive 1. X less than 1, x greater than or equal to 1. So first thing I'm looking at. All right, here's my piecewise function. This is negative 1. That's positive 1. This is positive 1. That's negative 1. Right off the bat, we can eliminate 2 graphs. Which ones? C and D. A and B. You see right here, the 2 graphs change equations at negative 1. Not positive 1. They're changing equations at negative 1. Over here, they change equations at negative 1. So the fence between the two functions is at negative 1. The fence that separates the pieces is negative 1 in these two pictures. Not going to happen. Maybe it's not going to be that obvious. I'm certainly going to look for it. Okay. So now the last two. The last two are very similar. You have a diagonal line going down to the right. It's falling like that. And then you have a horizontal line. And then over here in B is going down, negative slope, it's going down to the right, falling, and then horizontal. They're doing the same thing. The only difference between B and C. This one has a closed circle, solid circle here. Over here, it's open. Over here on C, it starts with an open circle, then it goes horizontal. Over here, it's closed, and then it goes horizontal. So in other words, think. This side, this left-hand side of the graph, is it sitting on the fence or up, just getting really close to it? It's sitting, so it equals, it owns the one, doesn't it? Over here, it's all the x's that are less than or equal to the one, and over here, it's for the x's that are greater than. Over here, because it's an open circle, this is when you have x just less than a one, and over here, because that's a solid circle, this is for x's that are greater than or equal to one. That's when you have a solid, that's when you have an open. Equals is when you have a solid. Open circle is when you don't have equals. So, according to our graph, less than one should be open or closed. Open. Less than one, whoops, not you. Less than one should have an open circle. So B. That's the only difference between those two pictures. Don't just stare at it. It's kind of like when you're supposed to like get two pictures in the old magazines when you used to go to the pediatrician, the doctor, and two pictures to like, what's different in this picture from that picture, and trying to find the difference. And your eyes are getting cross-eyed because you don't know what you're looking for. You're staring at every tiny little corner. Well, you don't have to stare at every tiny little corner. This is what's defining it right here. Those are your clues. When do we have a solid point? When do we have an open point? That's how you tell the difference. Okay? You gotta know what you're looking for. And if you haven't practiced it, or if you haven't seen it since, we did 1.3. Actually, we've graphed these at 1.4. Okay? The number 72, 75, then 74, or 74. So this is multiple choice. And it is determine which equation or equations may be represented by the graph shown. There may be more than one correct answer. So for 73 and 75, you have a single picture, and then you have 5 different possible equations that would represent that picture. And you have to figure out which of those possible equations would make that work, would fit that graph, or would fit that way. So which one do you want to 73 or 70? 73. Okay. So it's an absolute value. Okay, absolute, they're all absolute values. All right. Can't eliminate anything. X equals A, absolute value of X minus H, and then a plus M. In this picture, is it going up or is it going down? So in this picture, A has to be, is it greater than 0 or less than 0 in that picture? It would be greater than 0 because it's going up. It has to be a positive. So look at all of my possibilities. That's a 1 times absolute value. Question. 1 times absolute value. That's positive. That's a positive absolute value. There's a positive out here. That's 2. That's a positive absolute value of X minus 2. That's a positive times absolute positive right here. But here it's 1 minus this absolute value of x. There's a negative in front of the absolute value. F is going to be pointing down. So there's no way it can be up. Eliminate that. And then, is there a horizontal shift? Did it move left or right? Did it move left or right? Did it move horizontal? Yes or no? Yes. Did it move up or down? Yeah, because it normally likes to hang out at the vertex right here at the origin. So did it go left or to the right? It went to the right. So H inside would have to be a positive number. Wouldn't it? H would have to be positive. So if H would be positive, we would have to see X minus a number, because we would take out the opposite sign. H is a positive number. The negative is always built in. So let's say that this is a 12. It would be X minus 12. So when you look at the equations, you would see X minus 12. You'd see a negative in there. Opposite sign, positive 12. Okay? Right here, this H is a negative 2, the opposite sign. This equation, this function, is shifting to the left 2 units. Because this is a positive, the H is a negative. It can't be A. It cannot be A. That's a minus 1. Because it's a minus, it's going to go to the right. B is good looking. That's a minus 2. Because of the negative, H is a positive, it's going to go to the right. That's looking good. X, again, minus 2. It's a built-in negative, H is a positive 2. So that's looking good. This isn't simplified. So let's just clean that up. X minus 2 plus 1, so that X minus 2 plus 1. What's negative 2 plus 1? So it's just the absolute value of X minus 1. Right? So E, they didn't clean it up. They didn't finish it for us. E, rewriting it, is f of x when you simplify, absolute value of just x minus 1. So the H right here, this H is a positive 1. So this H is a positive 1, so that's okay. This H is a positive 2, so that's okay. This H is a positive 1, so that's going to the right. This H is a positive 2, so that's okay. So right now, B, C, D, and E are possibilities. We need A to be positive and H to be positive. Right now, B, C, D, and E. We've eliminated A and F. And we did say that there's a vertical shift. It shifted to the right, so H was positive, and shifted up, so K is what? Positive or negative? K is going to be positive. Keep the sign on K. So K is going to be equal to positive. So plus a K. We've already eliminated A, so you don't go back to it. K is a positive 2. K is a positive 1. So B is looking good, C is looking good. Is this a positive 2 or negative 2?
Positive.
Positive, huh? Looks like a positive to me. You see how they just rewrote it? They actually flipped it around. It's the absolute value of x minus 2 and a plus 2. Let's just say. But if they just rewrote it in a different order to mess with me, not to mess with us. Make my life harder to teach you. but it's still a K value. And that K is still a positive. So this one actually works. But what is the K value here? Is there anything outside of the absolute value? This K is 0. There's no vertical shift for E, so it cannot be E. So the three possibilities, B, C, and D, could be answers to number 73. B, C, and D would all, they would all give us that graph in one way, shape, or form. Now, is there one better than another? I don't know, because they don't give us any numbers. What I'm looking at, what I'm observing, it looks like this is longer than this is. That look like it. But we don't have any scale. They didn't give us any numbers. You know, yeah, if this is 1 and that's 2 and that's 1, it makes more sense that it moved further to the right than it did up. But what if this was 1/2 and that's a 1? Well, it's all about scale. They don't give us any scales. So any one of these is fine. As long as it went to the right and then up, to the right and then up, to the right and then up. Okay? Those are the pieces of the puzzle you try to take apart. $76. Now, 76 is a x to the third. Now, we're not going to worry about testing on an x to the third, but the same rules apply. A negative flips it from right side up to upside down. A shifts it left and right. K shifts it up and down. So what do you want to see, 74 or 76? 76? So f of x equals a parentheses x minus h to the third power plus a k. A equal to positive, it does this. That's our right side up. If a is equal to a negative, everybody flips, and it starts up here and it goes down like that. Horizontal shift, vertical shift. But what are we shifting? We're shifting this gap. That's the HK. Because that's where it crosses the x-axis. Okay? Opposite side as usual. So I'm looking at this. The normal parent graph of x to the third is negatives and then positives. Did it flip across the x-axis? Did it reflect? This is what it normally looks like. Negative numbers cubed are negative, positives cubed are positive. Is it going from small numbers to big, or is it going from positives to negatives? These y's are positives, and then they're turning negative. It got flipped. So there's a negative in front. This one has a negative in front. Got flipped. So let's see. A has a negative in front. So does B. So does C. E doesn't. It's on the inside. The inside is something completely different. Don't worry about it. E, positive in front. F is on the inside. That would flip it somewhere else. Not going to worry about it. So we can eliminate D and F. it was shifted to the left. If it's shifted to the left, then H has to equal a negative. If H is a negative, then it would be X plus a number on the inside, wouldn't it? Because it would be the opposite sign when you take out the H. The horizontal shift is a left, so it would be X minus a negative. We see a positive on, this is the only one that has a positive on the inside. The only possible one would be B. That's the only one that goes X plus. The other two are going to shift to the right. X minus 4, that H is a positive 4, we're going to the right 4. X minus 2, H positive, that's going to the right 2. So B is the only possibility. 1.6, 1.7 is lots of substitution and simplify, but also a lot of, are you paying attention to the ordered pairs and looking at pictures? 1.6, operations with functions. Adding, subtracting, multiplying, and dividing functions. And then one other one you may not have seen before, which is composition. So the first operating, sum. The sum of two functions. Here's the notation, and you got to get used to seeing the notation. I have to see this when you do a test. You don't show me this, you lose points on the first step. When we see this notation, f plus g, function f plus function g of x. Function f plus function g of x. It's not distribution because these aren't variables. You're taking function f plus function g of the variable f. The first thing I want to see you do is rewrite it as its definition. Function f plus function g of x means take function f of x and add function g of x to it. Add the two functions together. Ta-da! This is where, okay, you mean when you have plus, you just add? Yes. That's very nice. F plus G of 3. Here's what I don't want to see. Work over here, work over there, and you have like at the end, put it all together. Expand it, rewrite it. This means function f of 3 plus function g of 3. F plus g of the number 3, put 3 into each one, and then add those two together. Because now it's just substitute and simplify. F plus g of 3 is equal to, we're going to put 3 into the f function. Now, parentheses are going to be your best friend, provided you remember to use parentheses when you have to. Remembering to use parentheses when you have to is the trick. So if you just use parentheses all the time, you won't have to worry about needing to remember it when you have to. It'll always be there. I want to add this function with 3 plugged in. So here's f of 3. 3 goes in, I get 2 times the 3 and then a plus 1. That's what f of 3 is doing. And then we have plus. And then here comes g of 3. We plug 3 into the g function. Whatever goes into g, we square it. So 3 is going to get squared. 3 is going to get squared plus 2 times 3. And then a minus 1. So this is what it looks like when you put 3 into the f function, plus in between. And over here is what we get when we plug 3 into the g function. Substitution. Now we simplify. Simplifying is just order of operations. Order of operations. F plus g of 3 equals. So F, 2 times 3 is 6. 6 plus 1. And then we have plus. And you see it keep going from left to right. And inside this parentheses, we have 9 plus 6 minus 1. F plus g of 3 is equal to 6 plus 1, that's a 7, plus 9 plus 6 is 15. 15 minus 1 is 14. So plus 14. F plus g of 3 is equal to 21. I want to see this. The rewrite. I want to see the substitution. Now, do you have to go to all these steps to, do you have to show this step to get to 7? No. 6 plus 1 is a 7. 9 plus 6, 15. 15 minus 1 is a 14. Don't make me take away your calculator. You can show that much more. I'm going to have to do this one. What is F plus G of just X? You should be able to do anything now, because you know what to do when it comes to F plus G. You're going to add them together, and you know what to start with. The rewrite. You rewrite it. This means function f of x plus function g of x. Add the two functions together. I see f plus g of x. Okay, that means f of x plus g of x. So then we go, all right, f plus g of x is f of x. Well, what in the heck? Oh, f of x is 2x plus 1. So that's going to be 2x plus 1. That's my f of x. And then plus, and then g of x, x squared plus 2x minus 1. Now, I don't have to put parentheses when it's addition. When you add, it's not going to change any signs. Adding doesn't hurt us. Subtraction is going to be a pain if you don't put parentheses. So putting parentheses when you don't need is not going to hurt you. When you do need it, you need to have that bracket. So again, happens. So we simplify f plus g. That is equal to inside this parentheses. I can't do anything with 2x plus 1. So 2x plus 1 plus x squared plus 2x minus 1. I can't do anything with that. Nothing simplifies. So when I add x squared plus 2x plus 1, add a positive, it stays positive x squared. Add a positive to it, that stays positive to it. Add negative 1, it's now, or stay negative 1. So if you don't put this step here where plus and you have parentheses around each one, it's not gonna, I'm not gonna take off points. Because if you don't put parentheses and it's a plus, it's not gonna hurt. You've got to clean up. Simple. Get used to this. You need the biggest power first. You want to go from the highest power of x, highest degree, to the smallest degree. So the biggest power in that polynomial is x to the second. So we go looking for all the x squareds, and there's only this one. So we have 1x squared. Then we go looking for x to the first. There's a positive 2x, and another positive 2x. 2x plus 2x is 4x. And then x to the 0, which is the constants. 1 minus 1 canceled out. This is the answer. By the way, what was f plus g of 3? 21. If I asked you, what is f plus g of 9, or f plus g of negative 4, f plus g of 37, and a whole bunch of others. Could you imagine having to do this for 3 more, 4 more problems? Or, you know what? If you figure out what the answer is with x's, if I would have done this first and got the answer with respect to just an x, I can just plug this in and I can get the sum no matter what I plug in. 3 squared plus 4 times 3. 9 plus 12 is what? 21. So now if I actually want to do the sum of f plus g of 9, f plus g of the negative 4, f plus g of the 37, I wouldn't do 3 more brand new problems. I would just plug 9 into here, negative 4 into here, and then 37 into here, and do it right there. Because I have the formula for f plus g no matter what. Okay? But if I'm just going to ask you one number, why figure this out when I just put one number in over this? Okay? The sum. Well, if we can add, we can subtract. Here comes difference. f minus g. F minus g of x, just like we think it is function f of x minus function g of x. F minus g. F minus g of 5. Function f minus function g of 5. So first thing, rewrite. This means f of 5, and you're going to subtract g of 5. F minus g of 5. We're going to put 5 into the f function. So that's going to be parentheses. 2 times x is now 2 times a 5 plus 1. And then we're going to subtract g of 5. This is where parentheses absolutely have to go in when you subtract more than one thing. Minus 5 goes in, we get 5 squared plus 2 times 5, and then a minus 1. So this parentheses, 2 times 5 is 10, 10 plus 1, that's an 11. And then we have minus. We have to clean up that parentheses. So 5 squared, 25. 2 times 5 is 10, minus 1. 25 plus 10 is 35, minus 1. 35 minus 1 is 34. So it's going to be 11 minus 34. Four. F minus g of 5 and 11 minus 34, which is negative 20. Numbers are bad, and you'll have lots of numbers to plug in. But you'll also have to do this with variables. Okay. Rewrite. So rewrite is function f of x minus function g of x. So f of x, f minus g of x is equal to function f of x is 2x plus 1. So it's 2x plus 1. This function. And we're going to subtract g of x, which is this trinomial, parentheses, x squared plus 2x minus 1. F of x minus g of x. You might end up with the right answer, but if you did not put a parentheses around x squared plus 2x minus 1, if you got the right answer, but you do not have this step, There is no way to get to the correct answer without parentheses around that step. That's where I put this on a test. You have the right answer, I put it here. Work does not justify answer. Because how you got from what you have to what the final answer is, you can't get there. So you lose points. You might have the right, but it works out of justified. Which means you probably in your head knew you're supposed to distribute the negative, but because you don't have a parenthesis, there's no reason to distribute the negative without it. Work back. Get used to it. In here, we can't simplify 2s plus 1. This parenthesis, you can't simplify, so now we want to subtract it. Since we're going to subtract this, all the signs are going to change. When you subtract a positive x squared, it becomes negative x squared. When you subtract positive 2x, we get negative 2x. When you subtract negative 1, we get positive 1. You distribute negative 1 like you're multiplying. It changes all the signs. And then you combine like terms. Gather up your x squareds. This is the x squared term. It's a negative x squared. And then x to the first. There's a positive 2x. There's a negative 2x. They cancel out. They make a 0. And then the constant, 1 plus 1. So let's see, tracing back your math education roots, you learn how to count, then you learn to add, learn how to subtract. After you learn how to subtract, you learn how to multiply. Next up, multiplication. Product of two functions. Function f times function g of x. F times g of x. That's the notation. Again, f and g in the context of a question, they're not variables, they're functions. How would you know? At the top in the direction says these are functions. So you have to play into the context of the question. When we see function f times function g of the variable x, here's the rewrite. It's just function f of x times function g of x. That's all. Multiply the two functions together. This time, we're going to do the variable part first. We're going to do f times g of x first. And then we'll do another. So rewrite it. Function f of x times function g of x. So what is function f of x? So function f of x, replace it with 2x plus 1. 2x plus 1. That function times g of x, which is x squared plus 2x minus 1. rewrite it so you know exactly what you're going to do next with it. And now you got to multiply that together. It's just distribution. Okay. Each term, one at a time, is going to distribute and multiply with each term of the other parentheses. So we're going to distribute 2x to these three terms, one at a time, and then we'll distribute the 1 to each of these three terms, and then we'll combine our like terms. So it's going to be 2x times x to the second, that is 2x to the third. Positive 2x times positive 2x. 2x times 2x, that is 4x to the second. And then positive 2x times that negative 1. 2x times negative 1 is negative 2x. So that first term has been distributed to all three terms in the other parentheses. And just focus on one thing at a time. Focus on the first term, distribute that one to everyone. Have you watched the introductions at a basketball game in a while? Or any kind of sporting event where they introduce the starters? And as they go out, first person's out there waiting. Next person comes out, and that next person, high five, and they stand next to them. Next person, high five, and they stand next to them. The next person, high five. They're like all the way down the line. Well, it's kind of like this person comes out, high five, one at a time. High five with this one, there we go. High five to that one, there we go. High five to that, there we go. High five there. One at a time. And then
How did 2x to the third? What is it to the second?
I have this weird thing where if I turn like that, that's this word. No. So what happened here? 2x times that x squared. I know it was a long time ago, but exponent. 2x to the first times x to the second, 1 plus 2 is how we get 2x to the third. You add the exponents. If you actually expand it, it's 2x, and then you have x times x. So we have x to the third. Okay. When you multiply the same base, you add the powers. So if I had 5x squared times 3x to the fourth, 5 times 3 would be 15. X squared times x to the fourth would be x to the sixth. That's 2 plus 4 as of the 6. Add the exponent. When you're multiplying, when we multiply, we add the exponent. A to the m, a to the n, m plus n. Okay. Nobody yesterday did Monday, Wednesday, and I know they're wondering, but they didn't bother asking. Because that's going to happen a lot. Glad you asked. But now we distribute the second one, the second term, and it's positive 1 times x squared. So that's a positive x squared. Positive 1 times positive 2x, that's a positive 2x. And then positive 1 times negative 1. 1 times negative is negative 1. Now we clean it up. The biggest power, the greatest power is x to the third. So we look for all the x to the thirds. This is the only term with x to the third. We have 2x to the third. Then we gather up all the x to the seconds. We have 4x to the second plus 1x to the second. That adds up to 5x to the second. 5x squared. Negative 2x, positive 2x. They cancel out. They make a 0. And then minus 1. So the product of f times g of x, 2x cubed plus 5x squared minus 1. If you were asked to evaluate what is f times g of negative 3? Two ways to go about it. Since I have this figured out, since I did this, I could plug it in here. F times g of negative 3. I mean, it's 2 times parentheses. Negative 3 is going to get raised to the third power. And then 5 times negative 3 to the second power. And then a minus 1. Order of operations. What do I have to do first right here? The exponent. So there's a 2 times. A negative to an odd power is going to be a negative. 3 to the third is 27. So that's negative 27. Negative 3 to the third, negative 27. Plus, I got to do the exponent. 5 times. Negative 3 to the second power. A negative to an even power is going to be a positive number. What's negative 3 to the second? Positive 9. Then a minus 1. So f times g to the negative 3 is equal to negative 54 plus 45 minus 1. So f times g of negative 3 is equal to, that's going to be negative 9 minus 1, negative 10. And here's the horrible tale. What if I made a mistake figuring out the f times g of x? Happens. What if I made a mistake when I actually cubed negative 3 to the third? Happens. Lots of mistakes that happen in that. If all I'm doing is plugging in a number, if that's all I care about is one number, rewrite. This means f of negative 3 times g of negative 3, and then just do this. So f of negative 3, we plug in negative 3. So we're going to get parentheses. 2 times x, 2 times negative 3, and then a plus 1. Times g of negative 3. So in here, the negative 3 has got to get squared. 2 times x, so 2 times the negative 3, and then a minus 1. So this is what we get when we plug negative 3 into the g function. Fewer things can go wrong, and this is what we get when we plug negative 3 into the f function. Two times negative 3 is negative 6. Negative 6 plus 1 is negative 5. Negative to the second is positive. That's a positive 9. 2 times negative 3 is minus 6. Minus 1. 9 minus 6 is 3. 3 minus 1, that's times 2. What's negative 5 times 2? -10. If you are not asked to figure out what is f times g of x, and all you had to do is figure out what is f times g of -3, if this was the only question, why go to all this risk of getting something who knows maybe wrong, and then try to plug -3 into this, when all you have to do is this? Okay. Substitute and simplify. And then product becomes quotient. Once we learn how to multiply, that's the learn how to divide. Quotient. Fractions. So the notation is f over g. Function f divided by function g of x is just function f of x divided by function g of x. As long as g of x does not equal 0. You cannot divide by 0. That's always the concern. Watch out for 0. And we'll see that example when we start doing some homework. I'm going to get to start with number 10. Of course, number 10 doesn't give you anything to actually plug in. Right. It's all about ordered pairs. If you don't have an actual f of x equals like 5x minus 3x, 3 what? 5x equals 3x minus f of x equals 5x minus 3. If you don't have something to actually plug a number into, all you have is a picture. It's about ordered pairs. You do it the same way. X and y are your ordered pairs. It's your values. So this question says we have a picture of f, we have a picture of g. So for number 10, in green is g. So here's g of x. This would be -3, 1. This is -1, 2. For a pair, this is 3, -1. And f of x, this is the picture of f of x. Right here is 2 negative. This would be 2, 2. Right here is -1, 0. And this is -3, -2. We want to evaluate and draw a graph of h of x, which is f plus g of x. We want to graph h. And h is the graph of f plus g of x. Okay? Which means h of x is basically the y values for this is the y values of f of x plus the y values of g of x. The only x's I know, the only x's I have numbers for, -3, -1, and +2. Those are the only x's I actually have answers for. h of -3 would equal f of -3 plus g of -3. You see what I'm just doing right there? I need to know what h of -3 is so I can plot it. I need an ordered pair. How do I get it? Well, h is defined as the sum of f plus g of x. So h of -3 goes into f of -3 and g of it. F of -3 is -3 plus g of -3 in green is a 1. What's -3 plus 1? -2. So when I graph it, h of x, when we plug in -3, we're going to get -2. And then -1 goes in. H of -1 is equal to f of -1 plus g of -1. F of -1 is 0. G of -1 is 2. What is 0 plus 2? So when -1 goes in, h of x is up here too. And the last one that I know is what happens at 2. So h of 2 would be equal to f of 2 plus g of 2. So h of 2 is equal to f of 2 is up here, it's a 2. And g of 2 down here is a -1. What's 2 plus -1? 2 plus -1. Positive 1. So the ordered pair for h, when we plug in 2, is here. 1. And so the graph for h does this. And it's the same x's as for f and g. So why should just these add the sums? Add the sum of f and the sum of g together, and that's your y value for h. That's what's going on. What I'm doing is when x is -3. When x is -3, the y value for h is 1 plus -3 on that -2. When x is -1, the y value is going to be this 2 plus 0 on that 2. When x is 2, the y value is going to be this 2 plus that -1. It's going to be a 1. You add the y's together. And 2x plus 5. And x squared. So on 14, yours 11 and 13 is homework. You're not using any actual numerical values. We're just doing it in terms of x. So 14a, we're doing f plus g of x. And 14b, we're doing subtraction. F minus g of x. For part C, we're multiplying. F times g of x. And here's the quotient example for part D, f over g of x. Be right. This means function f of x plus function g of x. F plus g of x. Take function f of x, 2x plus 5. And we're going to add function g of x to it, which is x squared minus 9. I'm using parentheses, that way I always remember to. And then we add them together. F plus g of x. In the parentheses, nothing we can simplify, so we can just drop the parentheses. When we add, the signs are not going to change, so we can just drop the parentheses. Plus x squared plus negative 9 stays minus 9. The last thing you need to do is rearrange it, gather up your like terms, simplify those things. F plus g of x. X squared is the biggest power. Get you the first. X to the first. This is the only term with an x to the first. So plus 2x. And then you have a 5 and a negative 9. What does that get us? Negative 4. Negative 4. Minus 4. And that's all we do. That's what f plus g of x is. And then you have evil subtraction. So you know parentheses out of your head. Look, even the question f minus g of x, you have two sets of parentheses there. You got one around the f minus g and one around the x. So parentheses got to be in your mind somewhere. Please put them. My goal is to it takes me on average anywhere from 20 minutes to 45 minutes to grade one test. Let's just say it's a half an hour. Half an hour, 40 students. Okay. That's 20. Well, what's half of 40? 1. It's 20 hours to grade one. Okay. Again, that's if it's a half an hour average. Once you get them all right and understand everything you're doing, then I can get it done like in 20 minutes. Everybody. That's why I'm trying to keep putting that these parentheses. F of x minus g of x. So f of x is first. We have 2x plus 5. And then we're going to subtract this one, parentheses, x squared minus 9. Again, there's nothing you can simplify inside. So we drop the parentheses around the 2x plus 5. But we can't just drop it here. We have to distribute the negatives, which changes the sign. Minus positive x squared is now negative x squared. Minus negative 9, that's now plus 9. The sign change. And so f minus g x. Biggest power is x squared, negative x squared. Next biggest power, x to the first, 2x plus 2x. Positive 5 plus 9 is positive 14. Function f and function g of x means f of x times g of x. Function f is 2x plus 5, parentheses, 2x plus 5, this whole function, times g of x, which is x squared minus 9, that whole thing. All right, there it comes again. What is 2x times x to the second? 2x to the third. Good. Then a positive times a negative, we're going to get a negative. Positive times a negative, we're going to get a negative. 2x times 9 is 18x. And then we distribute the 5. 5 times x squared is positive 5x squared. And then positive 5 times negative 9 is negative 45. So f times g of x is equal to the biggest power is x to the third. Got 2 of those x to the thirds. Then we go look at her x squared. Yeah, we have an x squared. That's a positive 5x squared. X to the first gives a negative 18x. And a minus 45. And then B, the quotients, fractions. See if you guys are paying attention. What is the first thing you got to do? What? Why do you guys mumble? Because come on. Perfect. Rewrite it. Rewrite. Rewrite. This means function f of x is the numerator, and we're going to divide by g of x. Rewrite. And I don't mean just go straight to plugging stuff in, changing f of x to a 2x plus 5. Rewrite it in terms of f over g of x. Of the f is and the g's. Wait, that sounded weird. Boy, I had really a weird. It wasn't even a full power Freudian slip or anything. It just came out weird yesterday, just like this last one. Now I can go, all right, f of x is 2x plus 5. So 2x plus 5 is the numerator. In the denominator, x squared minus 9. That's what you're supposed to do. Substitute. Rewrite, then substitute. Simplify if we can. This one won't simplify. There's no common factor. You can't get the factor first. Nothing factors, nothing reduces. The question does ask about the domain. I'm not going to ask you domains on your test. Not for this. Okay. X squared minus 9 domain type of question. That would be chapter 2. So the next chapter after you take this. So that's all you do. That's as far as that one would go. So over here, 20 to 32 meters. Pick 2. 20 to 32 meters. Pick 2. Okay. Which one? 30. 30. One more. 26. So number 19 through 32, f of x is x squared minus 1. And g of x is x minus 2. On number 26, what is f over G of 0. So rewrite it. We want to know F of 0 over G of 0. Now, the rules about domain, they don't mean you can't plug 0 in. It means the function cannot equal 0 for whatever you plug in. We can't make 0 down below. We can plug 0 in as long as we don't get 0 after we plug it in. So let's see what happens if we plug in 0. In the numerator, that's 0 squared minus 1. In the denominator, that's 0 minus 2. So that's just 0 minus 1 over negative 2. So this is just negative 1 over negative 2. What do we get? 1/2. F over G of 0 is 1/2. But as soon as somebody says, oh, hey, 0 can't do that. No, you can plug in 0 as long as it doesn't make 0 as the answer. Okay. So F times G of 3t squared. Rewrite. So that's F of 3t squared times G of 3t. Plug 3t squared into F of x. Whatever goes in, 3t squared right here, you're going to square it. 3t squared is going to get squared. So this is going to be parentheses. 3t squared is going to get squared and then a minus 1. X squared minus x times G of 3t squared. 3t squared goes into G. So instead of x minus 2, it's 3t squared minus 2. Rewrite it, substitute, simplify. Simplify. What is 3t squared squared? You have 9t to the 4th minus 1. 3t to the 2nd, and then you square it. Rules of exponent. If you have a product to a power, then you raise each factor to that power. So that means I got to square the 3. And I still have to square the 2 takes. You know, 3 little pigs? Too bad this band had changed their name. They're called Green Jelly. They used to be called Green Jello. But the company that makes Jello. Sue them. But you can't call yourself Jello. That's copyrighted. And then they wanted to disassociate themselves with Bill Cosby anyway. Yeah. And then Ricky Sweat. So now we're going to multiply this together. Here we go. 9t to the 4th times 3t to the 2nd. 9 times 3. 27. T to the 4 times T to the 7. T to the 6. 9 T to the 4 times a negative 2. Will be a negative 18 T to the 4. Negative 1 times 3 to the second. 3 T to the second. Negative 3 T to the second. Negative 1 times negative 2. There it is. F times G. 3T. I'm going to hand out the review sheets. And there's one thing at 1.6 that I didn't get to, but I'll point it out up here. We're still going to finish 1.7 on Tuesday. Review next Thursday. Take one pound per hour. Make sure you pay attention so you know exactly what you're in for. You try to start this. Hello. Hi. Okay, so you can do everything that we have here all the way through the multiple choice examples. We just got done doing something just like this. That was number 19. Okay. Increasing and decreasing intervals. Here's the 1.6 that we've been doing. Okay. F plus G of 12. G plus H of -5. F minus G of -8. The functions are right here. And then F plus H of X. Subtraction. Multiplication. And then in terms of X, multiplication. Division right here. This number 20 is what we didn't get to. F circle G of 0, G circle H of -5, G circle F of X. These are the composition of functions. Composite functions. So 20, 21, 22, 23, and 24 are composition of functions. That's the last part of 1.6. That takes over 41, 43, 68, 70, those examples. It's, again, it boils down to rewrite it, substitute, simplify. But you just need to know how to handle that notation. So if you want to, you always can look at, I did finish that part in Monday, Wednesday. So if you want to look at Wednesday, yesterday's video, you can see what we did with the composition of function. If you want to wait until Tuesday's lecture, you can wait until Tuesday. We'll finish this up and we'll finish up 1.7. But we should be able to do all the way through 19. Not that you have to. Remember, the review sheet, and you'll turn it in. You only do the homework, 1.1 to 1.7. Okay. That's it. Remember, let me know if you were not here when I took roll.